This is our video for ETM9 about describing energy transfers. In addition to representing energy storage with a bar chart, we often use words to describe the energy transfer. These words are another representation, so it's important to check that this representation is consistent with any others. This word representation we've seen before, and this is related to skill 2A about checking multiple representations. Words are representation. This bar chart is a representation. We'll draw a picture. That will be another representation. And we need to check as we're making multiple representations that everything is consistent. So we're going to start, for this example, we're going to use our popper example. So I'm going to start with a sketch of the popper. I'm going to draw my EG equals 0 line on the ground to begin with. And I'm going to say moment A is when the popper is prepared. I draw a prepared popper like this to show that it's kind of folded in half. Like this is what the unprepared popper looks like, but when we have it prepared, when it's ready to pop, it looks a little bit different. So this is the way I drew my prepared popper. This prepared popper is not moving at moment A. From moment A to moment B, the popper pops up. We can see that happens, but it actually pushes against the table and it pops up. So we see that this popper has changed shape and it is now moving upwards. It is higher up off the EG equals 0 line, and it is moving upwards. So this is moment B. And then at moment C, it's probably up higher than we can see here, but I'm just going to make sure that it's up higher. Moment C, it has increased height. So we'll call this 0 height. We'll call this some height up off the ground. Or up off the EG equals 0 line, and here we'll call higher up than that. So this picture is one representation of this process that we see happen in front of us right now. Okay, so next I'm going to define a system, and my system is going to include the popper, it's going to include the earth, and it's going to include, let's say, the table. I'm going to not include the person in this system because moment A takes place after the popper has been prepared. So like moment A is right now, and my hand is no longer necessary to explain moment A. My hand is necessary to explain how we get from this to this. That's what question 3B was about, saying, okay, if the popper is unprepared, how does it become prepared? But at moment A, we no longer need the person to explain this process. This process happens without any people involved. So I'm going to go through, make my bar chart first. I'm going to start with the EK at A, and the EK at B, and the EK at C. I can tell it's not moving at moment A. It is moving significantly. It's moving quickly at moment B, and then at moment C, it is not moving again. I'm going to then move on to the EGA, EGB, and EGC. I can tell it's on the EG equals 0 line at A, so I'm going to put an X there. It's a little bit up off the table at moment B, but not very high. And it is really high up off the table at moment C. So I'm done with my kinetic and gravitational at each moment. Now I need to think about the elastic and the thermal. So I'm going to say E elas A, and E elas B, and E elas C. I didn't give myself enough room to do thermal energy here. I'll mention thermal energy in a moment. But my question here is, how how many blocks of elastic energy do I need at A to explain what happens at moments B and C? Remember, if we leave elastic energy and chemical energy and thermal energy until the end, we can say, all right, how many blocks do we need at moment A to explain the speed and the height that we see later on? So I can say like this prepared popper, this popper that's like kind of like bent a little bit, that's a different shape from its relaxed state. This is its relaxed state. This is its prepared state. I can say that it's storing 4 blocks of elastic energy. I know it's got to be 4 because that's the number that I need to explain the height and the speed that we see at moment B and moment C. I can also tell at moment B and moment C if the popper is in its relaxed state, it's not storing elastic energy at these 2 states. So this bar chart works. I could, by the way, if I wanted to, I could say that there was some impact there. That is, maybe if you want to make a complete bar chart, this has 1 block of thermal energy. I could leave that out too, but I would expect that if we're trying to do this really accurately, this collision between the popper and the table, that impact actually at least makes like maybe a box of thermal energy. But I'm going to simplify this for now and leave that out. So now that we have this bar chart, the last thing that we need to do is describe the energy transfer. And I want you to include this example so that you know how to do this in the future. Let's pay attention to this hint. When writing a useful description, always refer to changes in specific energy forms and use terms like conservation of energy, store, transfer, increase, and decrease. This is what we tried to practice when we were paying attention to that simulation, where we were saying, as that girl is riding the bike, chemical energy transfers to mechanical energy or kinetic energy. As she rides the bike, this wheel spins and the generator, this is called a generator, transfers kinetic energy to electrical energy, and so on and so forth. That's exactly what we want to do when we're describing this process here. So follow along with me as I write the following. I'll try to do this not too quickly so that you can follow along with me. When the popper pops up and changes shape back to a relaxed state, elastic energy stored in the popper transfers to kinetic energy in the popper's motion. Notice that I've used a lot of these words already. Store, I've used here. And this word transfer, I've used here. We really want to pay attention to using these terms as we write this description. So we're going to write, as the popper gets higher up off the table, parentheses, from moment B to C, kinetic energy transfers, again you see that word transfers, to gravitational And eventually you may want to use abbreviations here, but I'm using the full words so that we can read them as a full sentence rather than saying EK, EG. We're saying like, as the popper gets higher and higher, kinetic energy transfers to gravitational gradually. This word gradually means step by step, kind of like it doesn't happen all at once. It happens like as the popper gets higher, that energy transfer occurs. The last sentence I'm going to put a star by because this is a very, very important part of the description. We're going to say, because of conservation of energy, I'm going to use abbreviations here, the EK has to decrease if EG increases, so the popper slows down as it gets higher. And we're done. If you need to go down into this space, you can, but we want to leave some of this space for you to make notes to yourself on how to make these as useful as they can be for you.